Hello students, today we are going to learn about two electronic devices. Those are decoder and encoders. These are digital devices and there will be a simple explanation, and by the help of simple diagrams you will easily learn that what are these devices and how they work. Okay, so directly coming to the topic, see what is a decoder. Decoder is an electronic device which converts digital data into analog signals. This is the formal definition. However, in simple words, decoder is a device in which if some binary input is presented, then it converts it into binary output. Okay. However, in the output there will be only one and rest will be zero. Means suppose I say to the decoder the input is 011. This is binary data. So the output can be 1 0 0 0 and then 4 times 0 more, or 0 0 1 0 0 0 then 0 0 more. Okay. So what we see that in the output there is only one high or one. Okay. Rest of all are 0. Similarly, if in the input of decoder, if there are n bits, then the output will contain 2 to the power n bits. In case 4-bit input is there to the decoder, then here n is what, 4, then in the output there will be 16 bits. So in this example also you can see there are 3 bits input. The output will have 2 to the power 3, 8 bits will be there. This is the reason that I am showing you 8-bit output. Okay. And digital decoders are commonly used to access memory element in a RAM. One of use of decoder is in the RAM. Whenever the processor accesses the memory element, then decoders are used to access through that address. Okay, this is a decoder with its circuit. 2 into 4 decoder means 2 is the input and 4 is the output. You can see 4 output pins are there and two are the inputs, A and B. Okay, now you can see inside it that there are 4 AND gates. Okay, and to the inputs of AND gate sometimes some NOT gates are used. You can see for this first AND gate there is a NOT gate. One input is free, other contains a NOT gate in series. Similarly, for the second AND gate you can see one input is with NOT gate, other is free, and the third AND gate you can see both the inputs contains NOT gate, and the fourth both are free. Okay, and parallelly all of these are connected to these inputs A and B. You can see either you take this or take this or take this or take this. Okay, so all these AND gates and NOT gate systems are parallelly connected to AB. Okay, now suppose I say that I input 0 and 1 to AB. Now 0 and 1 will go. Now what will happen that AND gate only outputs 1 in case both the inputs are 1. Okay, so when 0 will go to this first AND gate, so what will happen, since first terminal is free, so 0 will go as it is, and other will be 1 is going inside, 1 will convert it into 0, and we know this thing that for an AND gate, in case any one input is 0, the output is 0, so it will output 0. Okay, now for the second case, 0 is going inside, so this NOT gate will convert into 1, and second input is 1, so that is already 1, so 1 and 1 input will be there, so this will output 1. The third AND gate, you can see when 0 will go inside, it will convert into 1. However, when this 1 will go inside, it will convert into 0, so any 1 is 0, it will output 0. And same case for the fourth, in which 0 will go inside from one terminal, other is going 1 itself, so any 1 is 0, then it will output 0. So you can see that in the output only one bit is 1, other are zeros. Similarly, in case I change the inputs, in case it is 1 0, then for 1 0 you can see if 1 goes to the stop AND gate, you can see 1 is going inside and 0 is coming, 0 will convert into 1, so 1 1 will become 1, so 1, and others will be 0, you can check it out. Okay, so 1 0 0 0. Similarly, in case the inputs are 0 0, then this AND gate will work, which contains two NOT gates, so these both of these 0 will convert into 1, so input will be 1 and it will output 1. Similarly, for 1 1 it will work. Okay, now I will tell you one of a practical use by the help of which you will learn it properly. Suppose I say I am connecting the outputs to the light bulbs of 4 rooms. You can see the output of first AND gate connected to room number 1, for second, room number 2, for third, room number 3, and for fourth, room number 4. Okay, so right now the inputs are 1 and 1, so it will develop output for this last AND gate, because for this case only 1 and 1 is the input, so it will output 1. Other are 0. So what will happen? Only fourth room bulb will glow and other rooms bulb will not glow. Just by changing the codes, I can control that which room's bulb will glow and which room's bulb will not glow. Okay. Now this is 3 into 8 decoder. One more example, that was 2 into 4 decoder. This is 3 into 8 decoder. You can see that there are 3 are the inputs. I already told that in case n is the input, 2 to the power n is the output. So 3 input will be there, then 2 to the 3. So that means 8 outputs will be there. So all these AND gates are, you can see, have a closer look, that all these AND gates have three inputs, you can see, and these red circles are for NOT gates, means before input there are some NOT gates. Okay, all the AND gates have three terminals, three inputs, and all the three inputs are connected, you can see, parallelly to ABC, the inputs, you can see. So I have shown all the inputs in different colors so that you can easily visualize the connections of each and every AND gate. Okay, so can you tell that for which case this first AND gate will output 1? In case the bit is 1, second central bit is 1, and third is 0, because 0 will convert it into 1 by the help of this NOT gate. So in case I ask you that for this AND gate, from the top second one, in which case it will output 1? Simple. It contains the first input and the third input, you can see, contains NOT gate. So in case I input 0 and then 1, because center input has no NOT gate and third input has a NOT gate. So 0 1 0, in case input is there, then second AND gate will output 1. Okay, so like this. Now suppose I am giving some input to ABC like this. So it is 0 1 1. Okay, so 0 1 1. So you can see that this fourth AND gate, which contains one NOT gate. Okay, I have shown it by yellow connections, you can see. So 0 goes inside, it will convert into 1, it will go inside, become 1, and then B1 is going inside, C1 is going inside as it is. So it will output 1. Okay, the inputs are rendered parallelly to all the AND gates. Okay, but only this fourth one will output 1, others will be 0. You can check it out. Now, what is happening here? That input is of 3 bits and output is of 8 bits. You can see. So input is from left hand side, ultimately output is toward the right hand side. Now suppose I want a device in which input are these signals. See, decoder converts digital data into analog signal. Okay, so in case I want these analog signals back to digital data, means reverse action, in case I want, then I have to use encoder. So this is what the difference between decoder and encoder. In decoder, digital data converts into analog signal. This is called as analog signal, and in encoder, analog signal converts back into digital data like this. So this is 8 into 3 encoder. Okay, so 8 inputs are there and it will convert into 3-bit output. Okay, now you can see that all these 8 inputs which are coming to this encoder are connected to diodes. Diodes are electronic devices through which current can go only in one direction, because we know this thing, whatever signal is coming, say 1, when 1 is coming, it is a form of current, electric current. Okay, so when 1 will come, it can go toward left hand side but cannot reverse back. Okay, so what you see, that in case you take this first diode, so output of this first diode is connected to A and B by these blue connections. Okay, C is not connected. So in case 1 comes to this diode, okay, then 1 will be the output of this diode. So that 1 will go to A as well as B. So output will be what? A becomes 1, B becomes 1, but C is not connected to this output. So 1 1 0. Similarly, in case 1 comes to this second diode from the top, then by green connections you can see that this output of this diode is connected to A as well as C, but middle B is not connected. So when 1 comes to this second diode, so 1 will go to A as well as C, but B will be 0. So 1 0 1 will be the ultimate output. Okay, so here I am taking an example. Suppose 1 is coming to this fourth diode. So this fourth diode is connected to this B and C by these yellow connections. Okay, and A is not connected. So the output code will be 0 1 1. Okay. Similarly, one more example. Suppose 1 comes to this diode, third one from bottom. Okay. So it is connected only to this middle B. This is A, this is B, this is C. So this B it is connected. So 1 will go there. Rest of the two are not connected. So the code generated will be, output will be 0 1 0. Okay. So what is the job of encoder? The job of encoder is reverse of decoder. It converts analog signal into digital data. The decoder converts digital data to analog signal, but encoder is just contrary of decoder. It converts analog signal into digital data. Okay. Now in the encoder, the input will contain n bits. However, only one bit will be 1. You can see over here that this is the input. Okay. So all the inputs are 0 except 1 1. Similarly here also only 1 1 is there and rest of all are 0. Okay. So in the input, among all bits only one bit will be 1, others will be 0, and it will convert into shorter code. Means suppose I say that input to an encoder is 0110 or 0001, then it can convert into short code, this 0110 to 01 and 0001 to 11 like this. Okay, now you can consider it like this, that if 2 raised to power n bits are input to the encoder, then the output code of encoder will have n bits. For example, suppose 8 bits are there. okay, which are the input to the encoder. Then annually how much? It will be 3. 2 to the 3 is 8. It means in the output it will contain 3 bits. Here the example you have already learned. Okay. So by the help of this small lecture, you would have learned that what is decoder and how it works, as well as you would have learned about encoders also. Thank you.